Earlier this year, I went down a rabbit hole. What started out as a broken bezel ended up turning into a complete 3D printed laptop case for a very cool, very old laptop that I love and that I've been working on for a number of years. In that video, which I highly recommend you watch, we went through the different materials and properties for a home 3D printer, and is it really viable in order to print components of a case or the full case itself? One of the things that we ended up with was this material here, which is a carbon fiber reinforced PETG. This material is really solid, and I chose it both for its durability and flexibility because it couldn't be too rigid because there's a lot of strain on the cases themselves. So it needed to be flexible enough in order not to break, but this ended up being way too flexible itself. So when I had a company reach out and talk about their metal 3D printing service and ask if I had any projects that might fit the bill, I kind of had a crazy idea. And after some initial discussions and some modifications to my models, I came up with this: a fully metal 3D printed laptop case. This thing is 100% stainless steel. I know, it was completely nuts, completely impractical, but it was fun as shit, and it really allowed me to learn a lot about the 3D printing process when it comes to metal. So in this video, we're going to go through the exact technique that was used in order to print this in stainless steel, the modifications that I had to make to the model in order to account for some of the design tolerances, and some of the unexpected things that I had to do after I got the parts back. A little unexpected post-processing. Let's dig into how this absolute beast of a laptop came to life. I've got a great existing model, but there's two modifications I need to make before I send this thing in. The first is to add these aluminum case stiffeners. Now, these weren't part of the original model because I didn't want to print these as the material would be far too soft. I'd rather use the originals. Now that we're printing in stainless steel, that's a different story. I want to build these things directly into the case itself. The second part is changing the screw holes. Originally, I had these as threaded inserts, but since I'll be cutting threads directly into the stainless steel, I need to shrink them down to about 0.3 millimeters smaller than the screw hole so I can get a good tap. After I sent it over, their engineers had some concerns. There were a few spots on the models where there was high risk of loss, deformation, cracking, things like that. So I took some time to simplify the geometry, but not too much. Keep in mind, I wanted this to be a test of really the capability of this 3D printer. So I made some updates, sent it over, crossed my fingers, and 2 weeks later, I got this. As I unbox this, I want to say thank you to JLC. They reached out and offered their metal 3D printing services for free if I were to include it in a video for an upcoming project, and I couldn't say no. The process that they use is called SLM, or selective laser melting. The printer deposits thin layers of metal powder, which the laser then melts into a solid metal object. Once complete, it's removed from the build plate. It's now ready for post-processing, which sometimes involves an oven to heat the metal and relieve the internal stresses of the laser rapidly heating the part, but usually it just involves removing supports and cleaning things up just like any other 3D printing process. I've always known JLC for their PCB design and manufacturing, but I'd never really realized that they had 3D printing services, so it was super cool to be able to test this out. Compared to other 3D printing methods, it's not a cheap process. This case would have cost me about $700 US if they weren't providing it for the video. As I unpacked these pieces, I really didn't know what to expect. I made some changes to the model based on the concerns that the engineers had, but I also had to waive a bunch of issues that could potentially pop up. Two of the original concerns were that of cracking or loss of detail. Now, going through these things, the detail is actually pretty phenomenal and far above what I would expect for a metal 3D print. Also, I didn't see any signs of cracking either, and so even the very, very thin pieces on this came out really, really well. Where I do start to see issues is on these bezels. You can tell that they don't really lay flat, so we are getting some signs of warping. I'm not too concerned about these things because they're only about 1.2, 1.3 millimeters thick, and they'll be easy to bend back. Where I do have some concerns is the back of the display. Now, I reinforced this to be about 2 millimeters thick, and so bending this back is definitely going to take some effort. The keyboard cover came out absolutely spectacular. I was really, really happy with this. The amount of detail by the LED light pipes and even the clips in the back came out awesome. One of the things that I'm noticing is this matte sandblasted finish that makes everything look very uniform. Now I might actually choose to take that off because I really want this thing to look like a steel laptop and not something that's been spray painted gray. The last things to unpack are these small parts. Now, one is a battery door cover, but two are these display clips. I was actually really concerned about these clips because they're incredibly small and very, very detailed. They have this kind of undercut in this peg here where you can see a spring goes on, and even the latches are slightly bent back into one direction. So when I looked at these, they almost are perfect. So I'm really, really happy with what they've been able to achieve. The first thing I want to do is take off this outside sandblasted look of the case. I want to have a cool contrast between a raw steel on the outside and that kind of matte powder-coated look on the inside. All I'm doing here is climbing the sanding ladder, starting at about 220 grit and all the way up to 1500. I'm using water with a little bit of soap mixed in. This helps provide a more even finish, as well as gives me a little bit longer life for the sandpaper that I'm using. When we get up to about 800 grit, you can start to see some of the features of the steel underneath. I don't know for sure, but I'm guessing this is due to the manufacturing process, and what we're seeing is the artifacts of the layer lines and the stresses that are imparted on it, both in the melting process and in the heating process afterwards. It's at this point where you really can get the impression that this is a raw hunk of steel. Next, let's talk about tapping. Instead of putting in threaded inserts into plastics, what I want to do is cut threads into the steel itself so the screws screw directly into the case. You can do this using these hardened steel taps. Now there's two kinds I need for this project. One for the through holes and the other for what's called blind holes, or holes that don't go completely through to the other side. The normal tap has the sharp point at the end that helps you align in the hole itself, and it's much easier in order to start things off. But with blind holes, because of that sharp tip, you're never going to be able to cut threads all the way down to the bottom. You need what's called a bottom tap. The bottom tap is flat at the bottom and allows you to cut threads all the way down to the base. You notice that while I'm doing this, I start out using the normal tap because it's easier to get situated, but after that I quickly switch to the bottom tap on those blind holes. Tapping is one of those things where you just need experience. I like to use these hand taps because I can feel the threads being cut and I can feel when I'm applying too much pressure. You really need to be careful with these taps. They're made from a hardened metal, and if you apply too much pressure, they can snap off really easily within the holes. Ask me how I know. I'm using a cutting oil that reduces the friction and improves the effectiveness of the tap. You can see that as I go, I do a full turn and then I back off for a turn. The reason I do this is because the tap creates debris as it goes, and backing off within the threads allows the tap to clear some of that debris so you're not fighting against it as you continue. This is incredibly tedious work, but at the end, it's super rewarding because you're left with these perfect screw holes for your parts. Now for the more nerve-wracking bit, fit testing. Some less obvious issues like part shrinkage become obvious when you try to put it together. Now, as you can see here, I'm trying to fit this into the little 1mm slot, but it's just not going. So I break out my Dremel with my metal wheel and kind of hog that out a little bit. I'm pretty sure the issue here was just some artifacts for the print that was in a really tight space, but after I clean that up with my cutoff wheel, fits like a charm. Test fitting the actual circuit board was the one I was most concerned about. As you can see, it needs to actually fit within the confines of the case itself. The case was actually designed around the PCB, and all of the screw holes need to fit exactly as well. This is the thing that took the most time when I was actually working on the original model of the case. The dimensions actually look pretty good, but I'm seeing another issue here, and that's bowing. So the PCB isn't laying flat down to the bottom of the case. You can see as I kind of push around, it flexes down and up. It shouldn't do that at all. The PCB should be completely flat to the bottom of the case, and there shouldn't be any give when you push down on it. That's going to cause some issues later on. Aside from that, things are looking pretty good so far. All of the screw holes are lining up. The standoffs and pegs on the case are actually fitting into all the places they should be. So from a dimension standpoint, this thing turned out really good. Right now we're only test fitting, so keep in mind the whole bottom of this circuit board is conductive. All of these little pieces we don't want touching the bottom or even the sides of the case, so there's going to be a lot of work to be done to insulate the case from all of this, but right now we're just doing a fit check. After patting myself on the back, I found a pretty big error. As you can see here in the original, there's a little notch cut out where a piece of the keyboard can fit back in there. A notch that is pretty blatantly absent on the model that I sent in. I'm going to have to fix that, and it's not going to be easy. That's quite a bit of steel. Another area I was worried about is the slot where this daughter board sits. It has the LED indicators, and it's also the inverter card for the LCD. The little triangular slots that hold this card are probably the thinnest parts of the entire print. It looks like it fits, so I'm going to take the win. Sliding on the keyboard cover looks like the LEDs align to the holes pretty well, so another win there. The other issues we know we're going to have to work out is this bowing. Again, I'm not concerned about the LCD bezels because even when we put screws in there, it's going to turn out to be fine. The big issue is going to be the back of the display case. I realize I'm not going to be able to use force to bend this. It's far too thick and the walls of the display actually add to its strength. I could literally jump up and down with my entire weight on this thing and it wouldn't bend. How do I know? Yeah, well, I tried. So that leaves us with heat, and not just any heat. This is 316 stainless steel, which in order to bend needs to be at a temperature of about 750 to 1000 degrees Celsius. Now I could do this with a propane-based torch, but this MAP Pro burns at a slightly higher temperature, which allows me to get up to temperature quicker and allows for more even heating over time. I know that it's starting to get up to temperature when it starts to turn a dull red. When it starts to turn orange, I know that it's going to be flexible enough to bend without cracking and retain its strength. After it comes up to temperature, I put it on a stone surface, and I push down with pliers at the specific points where I think the bend is going to be most effective. It takes a couple attempts, but in the end I get it to a good place. I'm really wary of heating and cooling the metal too quickly to where it becomes brittle. The last thing I want to do is damage this part. Then I'd have to order a new one, and that one would probably have the same issues as this one too. When I get it to a good spot, I let it cool down naturally and move on to the rest of the build. One of the things I never had to worry about is grounding, conductivity, and insulation when I was working on the plastic case. Modern laptops that use metal cases are designed to be that way today. They take advantage of the metal for things like heat dissipation, but also they make sure that the metal is appropriately grounded so there's no risk of electric shock to you or to any of the components inside the computer. The internals of this laptop have none of that, so essentially what I need to do is insulate the circuit boards from all of the metal casing around it. Now I could just go nuts with some plastic film and a scalpel, but I want to take a little bit of a different approach. The 3D modeling software that I use is called Shaper 3D, and it has a drawings feature. Rather than trying to make awkward cuts with inside a case, I can export these views. This will allow me to actually use it as a template to overlay on some non-conductive material so that I can cut it out and then put that in the case to isolate the circuit boards from the metal case. Even though I work on a lot of vintage projects, there's still quite a bit that I do at my desk, which is why I need a really good chair. I really don't do product review videos, but I was in the market for a new chair, so FlexiSpot sent this one over in exchange for my honest opinion on some of its features. I chose the white on gray mesh option, and I gotta say that the material is really nice. It's really sturdy in the seat and in the back, and it's got this material that's woven into the mesh that makes it a little bit more soft than most of the kind of plastic feeling meshes that you generally see. Now, it does have an option for a footrest as well, so if you're the kind of person that likes to kick back in your office chair, then that's great, but this isn't something that I typically use. I'd say my favorite part about the chair is the contour of the back. It's got a really nice lower back support, it's got a really great headrest, so it really fits me. I'm about 5'9", and when I lay back in the chair, it fits really well, and that back contour still supports me when I'm leaning forward working. I'm also not the kind of person that really relies on a headrest too much because I'm usually leaning forward when I work, but it's got a lot of adjustment options, and that really carries through to the armrests as well. You can pretty much adjust them in any direction you want. The only complaint that I'd have is they tend to slip sometimes inadvertently as you're using them, but after using it for about a week, I kind of got used to it, so it's not an issue anymore. Head over to FlexiSpot.com, and they've got a lot of options for colors and materials and things like that. And they're always having deals as well. So if you're in the market for a new office chair, then I would definitely add this one to the list of ones to check out. So again, I want to thank FlexiSpot for sending this over. It'll make a really solid addition to the office. Now that we've exported the drawings, I'm just bringing them into preview on my Mac so that I can crop them before printing them at actual size. Again, I'm doing this so that I can have a real size version of something that I can print out and cut out a template that I can use on something like a really thick vinyl, something that's going to insulate the bottom of the circuit boards against the metal case itself. I'm starting with the top of the case because it's the least complex geometry, and essentially what I'm doing is I'm removing all of the parts of the case where I don't want the vinyl to be, so the only thing that I'm going to be left with is a template that I can use to kind of cut out the vinyl. Now I've got this about 0.3 millimeter thick adhesive backed vinyl that I think is going to be perfect for what I need. It's going to be more than enough to insulate all of the electronics that may touch the case from contacting the metal itself. I can use it on the top, I can use it on the bottom, and I'm going to go to town and kind of use really small strips. Anywhere I see metal touching metal, I want to make sure to isolate that. You're also going to see me labeling, and this is essentially to let me know that if I'm seeing the side that is facing up, then that's the wrong side of the template. Because if you think about it, I want to cut the vinyl on the other side, so I need to flip this template over. So this is just me kind of making sure that, you know, I'm not screwing up and wasting a piece of good vinyl when I start to cut this thing out. These gnarly looking things are tungsten carbide cutting bits, and I needed to pick up a set if I had any luck of finishing this project in this decade. I honestly didn't realize how tough stainless steel was until I needed to hog out that kind of 1/4 inch by 2 inch section. This took me probably the longest out of anything that I did on this project. It was hours and hours over a few days of slowly taking off layer by layer by layer of this stainless steel until I had hogged away enough in order to get that keyboard to fit. Trust me, there were a few times when I thought I should just bite the bullet and order a new case with the corrected model, but as you can see, we got there. This is the original case stiffener, and we finally hogged out enough for the keyboard to fit, so now we can move on, but not before we use our bits in order to clean up some other pieces of the case. Now, during the fit testing, I found other parts of the case that needed to be corrected just a little bit. I had planned on filing those down, but with our new tungsten carbide bits, I was able to make quick work of them. And we're really talking fractions of a millimeter off, distances here and there, something that I might not have even worried about if it was plastic that you could just squeeze in. But when it's metal, it really prevents things from fitting correctly. So this was a necessary step. At this part in the project, there's a sense of relief, but then kind of a sense of exhaustion too, really, because there was a lot more steps. This took so much longer than I had ever thought that it was going to take. Literally, I really thought that this was going to be, I send this off to a printer, either it was a complete disaster and didn't work at all, and I'd have kind of a fun video to kind of work through, or it was going to work out perfect because, you know, I had taken the time to do everything right. Clearly I didn't, right? So there were a lot of things that I needed to do, but it really just makes the project that much more rewarding. As I'm installing some of the base vinyl here, I'm cutting out around, you know, the circle section for the speaker, and I'm really just showing a little bit of what I'm actually doing to insulate this thing, because there was a lot more to do, really kind of find all of the metal contact points in the entire case. But really, as this thing comes together, you can really start to feel like this is a finished product. Another little detail that came up was these screen clips. So now keep in mind, these are designed to slide so you can open and close them, and the texture that was imparted on it by the sandblasting process made it pretty rough. And so what was happening is it was rough on rough. So what I had to do is I had to go back and grind down and sand down to make sure that anything that contacted metal on metal, that metal was smooth, so that when I installed these screen clips, you could have a very kind of smooth action and you didn't have to worry about about kind of it sticking or grinding or things like that. But again, just another small detail that I had to think of. As I'm finishing assembling the display, one thing you'll see is that there's still a slight bow to the bottom of the case. Now, I was hoping that by putting in the bezel, it would kind of push against the sides and flatten it out. It really didn't end up happening that way, but that's okay, because what did end up working is after I screwed it in to the bottom of the case itself, it really ended up making that flatten out that last little bit that we didn't get with the heat treatment. I have probably assembled and disassembled this model of laptop maybe 100 times, and as I'm putting in kind of the finishing touches and the final components, every time a screw goes in tightly, you drop a component in that just kind of falls into place, it feels really, really good, because you know that all of the work that you've put into the design and the modeling and kind of the post-production of it really is working out and is paying off, and that you're going to end up with a really, really cool, really quality product. As this crazy little project comes to a close and we finish up assembly, I'm just going to stop talking. I'm just going to leave you with a fun montage of the final assembly of finishing putting this together. So enjoy it. I'll come back in at the end to talk about a recap and what went well and what didn't, and just enjoy. There were a lot of elements on this where I thought that I was going to lose a lot of detail and then have to fit or sand down, but honestly, it was kind of the opposite. A lot of things I needed to actually sand down because I didn't account for the tolerances in the design, because I didn't really know what those tolerances were going to be. The fact that I was able to modify things after the fact with sanding and grinding it a little bit in order to make it fit this way is pretty freaking awesome. I did not expect that the first round of this thing was going to yield this kind of results. Now, as you can see, there were some issues with the manufacturing process. There were some warping, some shrinking, some bowing, but those were all to be expected, and quite honestly, JLC warned me of these when I was doing this whole process in the first place, but I didn't want to necessarily sacrifice the design because I really wanted to see how the pieces came out, and for all that it's worth, they came out beyond my expectations. The fact that I could modify a model, have it printed, and it come out in this way, in metal, is pretty amazing, and I'm super happy with the results. Now, let's talk about how practical this thing actually is. For a old vintage laptop like this, super unpractical. I mean, let's just call it like it is. Nobody wants a 25-pound laptop. They were trying to make these things lighter and not heavier, but in my earlier videos where I was having some issues with the strengths of the material, well, this thing kind of blew it out of the water, because this thing is an absolute tank. And I kind of love it. I mean, it's a spectacle within itself, but it's kind of freaking awesome, which is why I'm running Doom right now in order to kind of show the thing off, because I think that's pretty appropriate. So let's talk about why this is impractical for this laptop. So this laptop was never designed to be in a metal case, and you can tell. Now, there were definitely things in the old design that protected the electronics from touching the bottom or the top of the case in some sensitive areas. I had to go through and meticulously tape or put in a layer of protection in a ton of different areas to make sure that this thing didn't short out. And not just that, there are different isolated ground planes within each of these system boards. And when you couple those, for example, if the back dock connector was touching the case, the power connector was touching the case, even if all of that was ground that was touching the case, combining those things and having that kind of coupling could have some serious issues long term. The most noticeable would be interference with the video, with the audio. You'd see issues with the display flickering or jumping. You'd hear crackle within the audio. You'd hear that kind of interference. At worst case, it could actually damage some of the more sensitive components like the processor or any microprocessor that are on the system board. So I had to be incredibly careful, and a lot of it that I didn't show, in order to, when I got it into this case, to make sure that the case itself wasn't acting as a common ground, because that could be a serious issue. Now, modern laptops are used to being in metallic cases like MacBooks and things like that, and so they're designed for it. What would be really cool is if you took this concept and put something like a framework laptop inside it. And there are projects that are going on right now. In fact, you can find one in the framework forums that I can link from a guy by the name of Carl Butchka, who has done some pretty impressive work preserving this old early 90s keyboard and hooking it up to some really powerful modern internals and a modern display in this thing too. And quite honestly, for a cyber deck, for something like this thing it's so cool. It's just a freaking tank. And I really love how it came out. But practical? No, it's not practical at all. This was more an exploration on metal 3D printing and the kinds of things you can get both from a small scale and from a consumer scale too, when you think about these kinds of applications. I had a blast with this project. I really didn't think that it was going to come out this well, and quite honestly, I didn't think I was going to have to put in the amount of work that was needed in order to tweak this thing, in order to get everything to fit, in order to get everything working in here. But again, it was a really fun project. And this can be the basis for a lot of different things. But it's really cool to know that this kind of 3D printing is so viable and accessible to consumers today. So I really hope you enjoyed watching the video, and I hope to see you in the next one.